Hey guys. All right. All right. So welcome to this NAPI talk. How many of you have heard of NAPI? Oh wow, that's great. That's great. Cool. So this is going to be a joint talk between me and Michael Dawson, and I'm going to go through some of the high-level motivations and reasons why we did this, and Michael Dawson is going to dive deeper into the APIs itself and how do you use it. So let's get started. My name is Arunesh Chandra, and I am a program manager on the JavaScript and tools team at Microsoft. Work on Node Chakra specifically, and a lot of debugging innovations that are coming out. So I work with a really passionate group of people working on Node at Microsoft, and we are quite heavily involved in the community with different work groups and stuff like that. And we really want to make a difference with our contribution to Node. So that's about me.
Hi, I'm Michael Dawson. I'm IBM's community lead for Node.js. And I get to work with a great team at IBM where we've done some really interesting things like port V8 to platforms like PowerPC and S390, as well as done a lot of contributions in the community. If you are involved in any of the working groups or you've been involved in a bunch of work that James talked about earlier, you'll probably see one or more of our members participating there, contributing. And we really try and support all of the things that we see as being important for the future of Node.js. So back over to Arun.
All right. So apart from just the two of us, this NAPI has been a great community effort across many individual contributors and also member companies for the Node Foundation. So this has been a truly broad community effort for the most part. So thanks to all of them. Some of them are here, so we should be able to answer questions later on if you have more. So with that, let's get started. So let's start with the first basic question: what is NAPI? NAPI is an ABI stable API layer for Node native modules. This guarantees an ABI stability across different Node versions and also different Node flavors. So today, due to this lack of ABI stability, Node.js native module ecosystem suffers from breakage for every new Node release. So according to some estimates, there are approximately 30% of the module ecosystem gets impacted at every Node release due to these stability issues. This tweet from Dan Shaw actually covers this problem pretty succinctly. It says that the mission-critical Node native dependency is the #1 reason why people are not upgrading their Node versions in production. So this ABI stability actually reduces friction from upgrading to newer Node versions because now the production deployments don't have to really worry about compatibility across different versions of Node. And also it actually reduces the maintenance cost for native module owners who have to go and update their modules every time there's a new Node release happening. So this actually solves both of these problems in the native module ecosystem today. So the response so far has been really good. This is a chart of a native add-on NPM package that we have built for the backward versions like Node 6 and Node 4. And it has seen a tremendous amount of downloads in the last 3 months when it has been out. So this feature has been available since Node 8 as an experimental feature. And we are still kind of working towards trying to get out of experimental with more real-world usage. We are looking for more real-world usage of this API, so we'll certainly need your help on that. And Michael will be talking more about that as well. So we always get asked, like, okay, is it a new NAND? And actually, that is true. We can talk about how it is different from NAND. So NAPI is has a more complete isolation of from V8. You can compile once and run on multiple versions. Both C and C++ usage are supported. And we've been talking to the maintainers of NAND as well. And over the future of this project, NAPI is actually expected to replace NAND usage for native modules. With that, let me actually show you a demo. So just kind of to set this up, the demo here is about an app that uses a native module called level down to read and write from a level DB database. And typically an app like this, if you change the Node version underneath it, you'll have to recompile the native dependencies when you change the Node version. But with the demo here with NAPI enabled level down, the transition will be kind of pretty smooth. So let me show you something here. Is it visible? Bigger? Large? No. Sorry. Hopefully this works. Okay, so let's get to the demo part here. So in this app, I have just one. I have actually compiled the native modules already. So let me just show you that there's just one leveldown.node file that we're going to use for multiple versions of Node. So before we get started, let me just show you the package.json here for this app. And here we can see that the level down, we are using a private fork of level down, which is NAPI enabled. And that's the only native module this app is using. So with that, let me just, so I use a very nifty tool called NVS. It's kind of a version switcher. If you're working with multiple versions of Node, it's really helpful, and it works with Node Chakra as well. So I'm going to pick Node 8.6 and just launch the app here, node app.js. And it is running at this this endpoint. Let me bring this up here. Okay, so ignore these entries. So this is an app, as I said, it reads and writes from a level DB database using the native module. Okay, so this is running Node version 8.6 as the current time. So let's go ahead and write something to the database. So it says it wrote to the database at this time using a particular Node version. Okay, so this is just one part of the example, and I will kill this app. It's not running anymore, and I use NVS again to go and switch to a completely different version of Node, and this time it is going to be running with Node Chakra Core. And I don't do anything on this same folder here. I do just the same thing I did again, before, node app.js, and I go back here, run this app, and this is running with Chakra Core. It had read the entries that was reading that was written with a different version of Node, and now it can still write. So it's all happened without having to recompile your native code. So this is kind of a huge deal for people who are dealing with native modules in a production environment, and they have to change their versions of Node and have to recompile. With this, as the example I showed you, you don't have to recompile. And the module maintainers also, they just write their code once, and it works throughout different versions of Node. So with that, I will take it over to Michael Dawson.
Great. So now that Arunesh has sort of told us a little bit about what NAPI is, shown us a good demo of how it works, and given us the motivation of why we're interested in it, not having to recompile our modules in production, or even when we upgrade from one version to the other, say going from Node 8 to Node 9 to Node 10, or even going to a completely different VM like Chakra Core, just being able to build your module once. I'm going to start to dive into a little bit and tell you a little bit about what the API looks like, the shape of the APIs, the function calls you'll be working with, just to give you an idea of what it's like to actually use the NAPI when you're writing a module for yourself. So up here on the screen, I've got some subset of the examples. If you want to take a look and see what's in the API, well, there's a couple good places you can look. Of course, you can go to the standard Node.js API docs. I have the link there. It's fully documented. You can look at what all the function calls are. So if you want to sort of read about what's going on, have the description, the parameters, and all that, that's a great place to look. Of course, if you've checked out Node Core, you can go directly to the node_api.h file, and that will have all the, the function headers that you're going to be using. When you start to look at the functions, the couple things that you'll notice, the first is that they all return a status code, and we've tried to maintain consistency across the different functions in the API. So they're all going to return a status code, and that status code will tell you one of three things, really. If it's NAPI OK, that basically tells you what you requested was successful, you can just move on. It may tell you that an exception occurred. So when something goes wrong, it can either happen sort of at the JavaScript level, in which case you may have a pending JavaScript exception, or at the C level. So it may tell you, hey, there's, everything at the C level was okay, but there's a pending JavaScript exception. In that case, there are functions like, get and clear the last exception. So if you're potentially accepting and expecting that an exception could happen, you know how to recover from that. You can get the exception, clear it, and move on. Most of the time, though, you'll just do a little bit of cleanup and return, and that exception will basically be thrown as if that function had thrown that JavaScript exception in JavaScript. And if you catch it in JavaScript, great. Or if you don't, it'll pop up, and your process will stop with the stack trace and so forth. The other thing it can tell you is it can tell you like a specific C-level problem. So for example, it could tell you, well, you made a call to NAPI, but you didn't pass me the right arguments, or the arguments that you passed me were not the right type. So you may get a specific error code telling you one of those. If you get one of those error codes, the other thing you should check is, like, was there also a JavaScript exception? Because that may also have happened. So even though you may be able to recover from one, you maybe can't recover from the other. Again, I think 90% of the time people will just return and basically populate, let the error populate up the stack. The other thing you'll see is there's always NAPI-env, which is the first parameter. That basically is a context. It's opaque. You don't necessarily do anything. When your JavaScript when your JavaScript function gets called, or your C implementation of a JavaScript function gets called, you'll always be passed it to this env, and you need to pass it back into any call into an API. The last thing I'll point out here is you'll notice that because we've used the status code for the NAPI returns, any returns from your function, of what you're trying to request, is actually in-out parameters on the function call. So in these cases, for example, in the top one, you see like the result comes back in an API value, and so that there'll be one or more of those in-out parameters that gives you the actual output from making your function, if there is one. And I guess the other thing I'll mention here is you'll see an API value. That's an opaque pointer, again, that represent things like JavaScript objects, functions, and so when you're writing with the NAPI, you'll be using that type for a bunch of different things. So that's sort of a peek into what the shape of the API. Looking at a specific example, if you've worked with NAN, you'll know that there's something called NAN add-on examples, or the add-on examples, and it actually had examples of how to write native add-ons using NAN 10 and 12, just so it was an easy way to sort of migrate those common use cases between the different versions. We've extended those, so there's something we have Node stable, I think it's stable Node API or something like that, add-on examples. I have the link here. And we've extended it so that there's versions for the NAPI and for the wrapper that I'll talk about in a few slides. And it just goes through those same common use cases in terms of like how do you write the code using the API. So I've just pulled out one of those examples, the 3 callbacks, which is an example of your function being called from JavaScript. It's passed the function as one of the parameters, and then you take that parameter and you invoke that function passing a hello world string, just to give you an idea of what it would look like. The code's a bit too long to fit onto one page, so I have it on 2 pages. This page shows the setup where if you've written an add-on, it should look very familiar. We have our include. Instead of including nan or the v8 types include files directly, you include node_api.h to get the headers. And then you have your initialization function. That initialization function takes and exports, which you can either add things to and return, or just create a new one. And in this case, you can see I'm creating a new function with nappy create function, and I return that as my exports. And when I require that function, that's the require that module, that's the function that I'm going to end up getting, and when I call it, it will be invoked. And just like the nan node module defining your entry point, you use nappy module to define the entry point. In terms of the code itself, it's pretty straightforward. The nice thing about using a C interface, and NAPI is C-based so that we can ensure ABI stability. The nice thing I find about a C interface is it's pretty easy to tell from the functions what you can do. If you go through the documentation, you'll sort of have a good view of what the full surface area is available and how you do different things. So in this case, we start by saying, well, give me the callback information. I'm running a function that I've written in C. First thing I want to know is what are my parameters, and you use the get callback information to get that. It will give me an array of what was passed to me. We then start out by pulling out arg0, which I know is my callback function. And then I'm going to create a string. So this shows how to create a string with nappy create string UTF-8. So I'm saying hello world. I create a nappy value which represents that string. I want the global function to basically give the context that I'm invoking the function on. And then I use nappy call function to actually invoke that function. I'm basically saying invoke this callback, here's the parameter, hello world, and basically JavaScript has called C, C is called back to JavaScript, and you have the simple example. So hopefully that gives you a good feel for roughly what it'll look like when you're building out your modules using the core NAPI API. Now you may be thinking, well, wait a sec, I've used nan and it's C++ based, I prefer C++. So we know that that's one of the common use cases, and we want to make sure it's easy as possible for you to transition from that world. So not actually part of the core API itself, but a piece we've been working on very closely together is the C++ wrapper module. It's a Node add-on API. It's under the Foundation GitHub repos. It's also published as an NPM module. And what it basically gives you is C++ sugar that you can use in your applications to develop in a C++ type model more efficiently. But it ends up basically dissolving into just code which calls the standard C NAPI function call. So you still get the benefits of the ABI stability because you're effectively using only those C functions from Node, but you have this nice wrapper which lets you work in C++. As I said, it's deployed as an NPM package, so you can just NPM install it and start working with your modules. It's in the Node add-on API GitHub repo, so you can go there if you want to actually look at the code and actually contribute. And we do have some documentation for it. That's an area I'll talk a little bit more about later, but we also have a decent push going on now to build out better documentation. Flipping back to the same example that we had before, this is that three callbacks example. Like I said, in the ABI stable versions of the add-on examples, we've done versions for NAPI and for this wrapper. And this shows the examples, the same example for nan and for Node add-on API. You can see, again, it looks very similar. It should be comfortable if you've been writing nan modules. Instead of including nan.h, you include nappy.h. That's pretty straightforward. Just like before, instead of using node module, you use node API module to define your entry point. You still have your initialization function, which basically just creates a function. In this case, there's just a C++ object for function, which lets you easily create a new function, passing in your C entry point, which is run callback. And then in the actual implementation of the code itself, you can see it's as dense or denser than nan is, and you've got the C objects that let you create the function, create the string that you want to pass back, and it actually invoke the function itself. So, the resources you have there is the repo where you can look at those common. There's about 8 different common use cases, so you can go take a look at those. The other thing we do have is a conversion tool. So if you're starting with a NAN module, we have a tool that it's written in JavaScript, that will actually take your NAN module and convert it into an NAPI module. It only does maybe 80% of the conversion right now for you, but it gives you a good start for getting your module, getting up and running, and being able to start your conversion pretty quickly. Well, one of the main questions we always get is, okay, well, this is great. It's available in 8.x, but what about backwards compatibility? So as I said, it's available in 8.x. It's experimental. We are working, like a lot of the other experimental features that were mentioned, to get it into being non-experimental as soon as possible. So we hope to actually make that happen, if not in 8, soon after. We plan to backport it to 6.x. And for 4.x, we don't plan a backport. What we do have already is in that npm module, it actually includes a copy of NAPI, so you can write your module and compile against all the different versions. If you compile against the version in the npm for 4, you can't necessarily run against all the different versions, but you could at least have one version of your code that you can use with 4, 6, and 8. If you compile it with 6, after we backport it, you would be able to run with anything later. And we are working to actually do even better than that. We're working on a mechanism where we can dynamically load a pre-built shared library, and that would actually let us support backwards compatibility all the way back to 4.x. Not quite finished that yet, so it's not, not official, but we're hoping to get to the point where you have backwards compatibility across all the existing LTS versions. At this point, what we really want to do is we hope we've motivated you for why you're interested in it. I've shown you a little bit about the APIs and how you'll be working with it, and we really now want to make a call out to all module maintainers to get involved, to help push this forward. It's going to take a lot of work, and we understand it's going to take time to sort of move the module ecosystem over. But the more help we can get, the more people we can get involved in jumping in now, the better. So some of the things you could do is you could actually help to port some of the key modules. If we can get the top 30, we have a list of those, and our goal is to get those ported over. If you can help with that, that would be great. You could try out some of the ported modules. Feedback is always very important in this kind of situation. How is it working for you? You can help to improve the documentation. And in fact, that's an area where after Node Interactive, we actually have 3 volunteers who have stepped up, and there's a real active push to start building out the documentation for the wrapper. We already have really good documentation, I think, for the NAPI, the core NAPI, although it's always great to have feedback from people who are just coming in fresh. We have a lot of context, and so we don't necessarily see things that might be a bit trickier. But that's a great place to get involved. Test coverage, again, we have good test coverage for the core NAPI, shown in coverage.nodejs.org. But for the wrapper, we have a bunch of work to go. So that's another area where we've got a meta issue. If you go to the repo, it lists out all the objects and which ones we have test coverage for, which ones we don't. And that's an easy area to sort of say, hey, I'm going to learn a little bit more about the API and jump in and help by writing some of the tests for those particular functions. And we're starting to work on that ourselves as well. And if you're really interested and excited, you can always join the NAPI working group. We meet once a week to sort of prioritize the work we're doing, talk about what needs to get done. And so, we'd love to see you guys show up, participate, and things like that. Just to end up, useful links. I'd mentioned that there's the conversion tool. So there's this tool to help you convert from NAN to NAPI. That's something, again, where it does a decent job on the first 80%. If you convert your module and figure out that it could have helped you in a bunch of ways by doing more, that would be a great way to add in and contribute there as well. If you're starting a module from scratch, Hitesh built a Yeoman generator, which will actually scaffold you a project, which is what you need to build your NAPI module. So that's a great way to get started as well, to basically use that, get the scaffolding, and you can get up and running really easily. And then the last thing we do know is that there's going to be the transition period. So we have some guidance that we've thought about it. How do you actually have a version of your module that supports both NAPI and your existing users or versions of Node that don't support NAPI yet? And so there's a document there that sort of suggests the way that you can do that. And if you've got a module and you want to do that, that's a good thing to take a look at. So that's all we had. Hopefully we've given you enough information to get excited, interested, and hopefully even want to get involved to help make this happen. And we'll both be around the conference, so if you want to talk about it further, have any questions, just let us know. Thank you.